let's say you've got a mountain. And you're standing down here. From this perspective right here, you're looking up, aren't you? Would you agree? What does that look like it makes right there? What kind of triangle? A right triangle. Yes, it's a crude drawing. But let's say this is 30 degrees. Do you think this is an angle of elevation or an angle of depression? Because the person is looking what? From this perspective, it's an angle of elevation. However, say your brother already climbed it. He's sitting up here and he's looking down at you. From his perspective, this is an angle of what? Depression. It's that simple. So it is important what perspective you're dealing with. Does that make sense? This is an angle of depression with respect to this dude. This is an angle of elevation with respect to him. Does that make some sense? Okay. What you're basically going to have in this section are problems exactly like 8-4. The only difference will be from what perspective or kind of how we're looking at it. So let's look at number let's look at number 6 on page 583. Everyone try to draw that figure. I know it's easier said than done. I'm cheating, I know. Where's my rectangle? There it is. I basically need to extend this a little more. They say this is what? 15 degrees. Here to here is X meters, right? Here to here is 50 meters. Here to here is what? 15 meters. Now, what I'm doing is I'm in essence drawing the things that matter and not the actual picture. Am I? And not drawing the slides and all that stuff. Now, reading the problem, it says 2 water slides are 50 meters apart on ground level. From the top of the taller slide, you can see the shorter slide at an angle of depression of 15 degrees. If the taller slide if you know, I'm sorry, if you know the top of the other side is approximately 15 meters above the ground, how far above the ground are you? So where are they saying you are here? Let's read it again. It says two water slides are 50 meters apart on level ground. From the top of the taller slide, you can see the shorter slide at an angle of depression of 15 degrees. So where are they saying you are? You're at the top of the taller slide. Okay? So they're wanting to use this information to figure out how tall or how far you are. Now, basically, I know here to here is 15, right? If I find here to here, let's call it y, would I be able to add those two and know how tall this is? Would that make sense? Now, if you'll remember when we were doing trig functions, is this a right triangle right here? Okay, look for the right triangle. I need two things. I either need two sides or I need it, because remember there's three things, right? Cosine of the trig function of an angle is equal to, what, opposite over hypotenuse, something over something. I need two of those three things to be able to solve for one of them. Okay? So let's look at this. I only have 15 degrees up here in this triangle, don't I? But what else, if I look a little closer, do I actually have?
50 meters.
This here to here is the same distance as here to here, isn't it? So this one is what? 50, right? So if it helps you, basically, and this is y, correct? This is what they want us to find. If we find y, we can then add it to 15 and we'll have what? X. Does everyone agree? How am I going to find that? Using what? Trig functions. The information given to you will tell you which trig function to use. With respect to this angle, what has been given to me? The what?
Opposite and adjacent.
Opposite and what? Adjacent. Which one is that? So, toa? That's what? Tangent. So I would say the tangent of what angle? 15 is equal to my opposite, which is what? Y over my adjacent, which is what? Now isn't this just like the problems you've been doing? So what these problems are is the use of trig functions into everyday life. The only thing that makes these a tad more difficult is the reading. As I read that long thing, we kind of needed to look at it again to make sure, okay, where do they say I'm standing, right? Because they said, how far are you from the ground? Well, then we figured out, okay, you're standing right there by reading it again. But once you do that, it's just the same problem from previous sections. So what am I going to do? This is like, remember we had three types, 1, 2, and 3. This is like the first type we talked about, where the unknown is right there. What am I supposed to do? I put this over 1, cross multiply. Y times 1 is what?
Y.
Equal to 50 times, so this would be 50 times what? Tangent of what?
15.
Now it's about putting it in the calculator, isn't it? 50 times 15 tangent equals, what is y? And what did they ask us to round to? Nearest tenth of a meter. I got 13.39, so what would this be? Approximately 13 point what? Huh? 4 meters. So that's where y is. So if this is 13.4 meters, what is x equal to? 15 plus what?
13.
So x is what? 28.4 what?
Meters.
That was one of the harder ones. Make sure you've got this written down. You will have some problems saying, hey, is it an angle of elevation or depression? Things like that. When you guys got that, let me know.
Is Case and Jenkins here?
No, he's not. I forgot to get him out.
Alright, thank you.
Hmm? Everybody's done? All right, let's look at the, open our little red books. On these little red books here, when you have a person or a vehicle, do it from the perspective of the person. And since it's a house and an animal, do it from the perspective of the animal, from the living thing. Okay? The only one is number 1, there's no living thing. I would do it from the perspective of the helicopter. But every other thing, do it from the perspective of the living thing. Houses don't live, right? So what are you doing it from the perspective of here? What's living here? Person. Person. Nothing living here, so let's do it from the perspective assuming there's a living person there, right? Okay, we are going to do number 7. Let me freeze this up here and then I'll go to the board. Nice, big, pretty picture. Okay. You guys scoot over a little bit because I'm going to shine this on the board so we record. Okay. Turn one of those lights off, would you? Do? Yeah, you can see better that way. Good. Okay. Got a lot of information elevation to go through here. Angie sees a hot air balloon in the sky from her spot on the ground. Okay, the angle of elevation from Angie's balloon is 40 degrees. Okay, if she steps back 200 feet from, and the new angle of elevation is 10 degrees, we've got that in there. If Angie is 5.5 feet tall, how far off the ground is the hot air balloon? Okay. I would rather get rid of this, since it's, the reason they did that is because it's so small on the paper. But it's big enough up here where we can write 10 degrees right here. Okay. They want to know how far off the ground the balloon is, correct? Okay, so we've got to find x. Really, this right here, this 5 feet, really has nothing to do with this right triangle over here. Okay? Once we find x, to tell how far this is off the ground, what are we going to have to add? 5.5 what? Feet right there, huh? Everyone agree?
Yep.
Okay. What we're going to have to do is look at this in terms of two separate right triangles. This one is very hard. That's why I'm doing it. I won't probably expect you to do ones like this on your own. We basically have two right triangles. One right triangle like this, and it's helped sometimes draw these separately where this is 10 degrees, correct? And what is this? This is 200 plus what? Why? Would you agree? That would be this whole distance right here. Right now, I want you to watch, and then this will be on canvas, and I want you to, like I said, this is. Then you've got another right triangle where this is y, this is x here, and this is what? 40 degrees. What we're going to have to do is create a system of equations and solve this. Yes, you probably don't like that, but that's what we're going to have to do. First of all, I'm going to use trig functions and create my trig ratio here. What would it be? What have they given me? With respect to this angle, they've given me the what? And what? So that's what? So tangent of what? 10 degrees is equal to, what's the opposite? X over what? Fun. Over here, with respect to this angle, they've given me the what? Same thing, the opposite and what?
Adjacent.
So this is also what?
Tangent.
Tangent of, but this time what?
40.
Is equal to the opposite, which is x, and the bottom, which is what? Here's the deal. Solve each of these for x, or one of these for x or y, and then substitute it into the other one. It'll be messy, it'll be ugly, but remember, tangent of 40 is really just a number, right? So what if we solve this one for x? What would x be equal to here? Tangent of what? 40 times what? Okay. What if I solve this one for x? What would I get? Tangent of 10 degrees, or 10 times what? 200 plus 1. Now that I've got these two set equal to each other, can't I just plug this in right here? So I would get tangent of 40 times what? Y is equal to what? Tangent of 10 times 200 plus 1. Do you you see that I basically took this right here and plugged it in right there. Solving systems of equations, okay? Now, this is a big ugly mess, isn't it? It is because tangent of 40 is kind of an odd, weird number. It's in essence, this is like saying 3y is equal to 3 times 200 plus y. You see what I'm saying as far as, it's really just that. It's just a lot to write down, a lot to keep straight. Remember, this is just a number. So I'm just going to clean this up by writing it as tangent 40 y is equal to, what would be on the other side? Tangent of 10 degrees times 200, right? I need to what? Distribute times tangent 10 what? Y. Now, this is where it gets a little weird. Like I said, I need to get my y's on one side, everything else on the other, right? So you know what I'm going to do? I'm going to subtract tangent of 10 degrees y from both sides. And what happens here, and this is of y, right? So what I'm going to do is factor this out, and I'm going to say this is tangent of 40 minus tangent of 10, all in parentheses, y, is equal to tangent 10 degrees times 200. Next thing, I'm going to divide both sides by tangent of 40 minus tangent of 10. Tangent of 40 minus tangent of 10. Then you put that into your calculator. Now, probably what would have made more sense and been easier for you guys, and what I probably should have done, is at this point right here, what is the tangent of 40? Guys, tell me in the calculator. Let's do 4 decimal places. Point what? 8? 391.
I got 390.
No, if you round, it's one.
Y is equal to, what is tangent of 10 degrees times 200? We're right here. 35 point what?
2, 6, 5, 4.
Right? Plus, what's tangent of 10?
Um, 0.1763.
One. That looks a little more like something you're used to solving, doesn't it? It's just got, so, because of my more vast knowledge of math, I like doing this so I can put everything in the calculator at the end. You know what I mean? I don't have to write those decimals. But probably in all realism, and I'm going to scoot this over so we can see this, when you get a complicated equation like this with tangents and things like that, just take it to a bunch of decimal places so it can look more normal to you. Does that make sense? Yeah, I love how you do that. Because this right here, this equation right here coming from this right here, if we'd have done that, that looks a little more, it's kind of easier to see, come in, that we would what? Hey, stand. It makes more sense to do this. Now what would we do? This is just a y term. Now we subtract what? 0.763y. Subtract 0.1763y. What are those two subtracted? .8391 y minus minus 0.1763.
0.6518.
Y is equal to 35.2654. Now what am I going to do? My what? Is equal to what? What do you get?
54.1046.
So what did they say to round it to? Well, let's leave it at this because it's just Y. So we found Y now, okay? So, we found Y, but actually what do they want to know? How tall you are off the ground. So we've now got to find X. How are we going to find X? Well, I would use this one right here. I would change this now to what? What is Y? 54 point what? 1046. So in this trig function we can put now what? 54.1046. This becomes 54.1046. Can't you put that into your calculator now and find what X is? Tangent of 40 times 54.1046. By taking 4 decimal places, since they want us to round it, I think to the, what did they say? It didn't? So we'll go 100. You know you're going to be safe. What do you get?
45.3992.
So what's 45.40? Feet. And that's a different answer, so everybody put tangent of 40 times that in again and make sure we get it. That's some people get different things. Tangent of 40 is less than 1. If it's over 45 degrees, tangent becomes more than 1. So what, somebody put in what the tangent of 45 is. See, as it gets to 45, the angle gets bigger, so now the one on top is bigger than the one on bottom. Because you know, that angle has got to be bigger, so it's the bigger side now. When it's below 45, the bigger side is underneath, and it's on the bottom of the fraction. So this is what we got. So, what is our answer? 45.40 feet what? Plus 5.5 feet. Because she's 5.5 feet tall, right? So the answer is 50.9 feet off the ground. Okay? Well, 90% of 0.9 times 12. What's 0.9 times 12? Huh? So it's 50 feet. 50 feet, 10.8 inches off the ground. Or roughly, like you said. Very close to being 51 feet, huh? So as a little bit of this ought to show you how, just a little bit of the value of trig functions. How they're obviously something you would use for doing things like this in the real world. And that's what's good about it. Here's the deal, guys. Your assignment is the workbook, front and back, for section 8.5. You will turn this in, so when you do your review assignment, I'll probably, you need to do, what, 3 or 4 problems from the book work for your review assignment. If you'll look at number 6 on the other side, if you can get that one right, I'll give you extra credit, but I don't, I'm not going to put one like that on the test, so I don't want you to kill yourself. It's like this, okay? But as you can see, now here's the deal. I want you to do these on a separate sheet of paper. You don't have to rewrite the problem. You don't even have to draw the figure. I just want all your work on a separate sheet of paper, make sure I can tell what's number 1, what's number 2, label, because, you need some room. There's really not enough, that's why I didn't do it with the envelope. There's really not enough room on here to do everything I just did under here, okay? I did probably, on the book, I did probably one of the hardest ones you'll do that I expect you to do. Most of them were just basically give you a triangle and you do a straight function. Does that make sense? I mean, that's it. You don't even have to add something afterwards or anything like that. Okay? So, we're gonna do all of these. Like I said, number 6 is extra credit. Actually, number 7 is extra credit as well, on the back, if I remember correctly. Because this is what I signed last year, they're pretty difficult. And they're fun to try, but you know, I'll be honest with you, you're not gonna have that on the test, so I don't want you killing yourself on it. Everybody got that? Huh? No, your assignment that's due is the workbook. I'm trying to cut it down because we're gonna, you know, I want you guys to study, you got a lot to study. There won't be a lot of angle elevation on the test, it will be, you know, on the test, there'll be a couple problems, this is an angle of elevation, compression, that's kind of my way of saying, okay, here's a good easy one to get right on the test. And then, might be 1, maybe 2 problems of pretty easy, straightforward angle of elevation problems, which is just an extension of the trig functions. I've got it's gonna be an 80-point test on Canvas. I've got study, study, study. Okay? Study. Isn't easy. There's a lot to remember. I will erase that. SOHCAHTOA. However, I might put the geometric mean equation up there for finding the proportion. All right, let's get to work.
Ingenuity does for questions.
Hold on. Let me get this.